So in part 4 I built a steel frame, and on the top of the steel frame I mounted a plywood. On the top of the plywood I will mount a MDF plate, and the reason is that I want to make all this much stronger and more rigid. And as you can see, I want to use these screws I found here to mount the MDF. So the MDF will be mounted through the plywood, and I hope that this will really make a solid and good and strong. But the first thing I want to do is kind of look into how straight is the board now. I know it might change when I tighten down the MDF to the plywood plate, but anyway, I'm a little curious. So before I actually do this, I want to create you can see this is a simple way to put in a contact switch that I can use, set on the spindle itself, and then just go and measure the height in different areas and kind of create a height map. And this height map will be, you can say how straight it is or not straight. So I start up looking into the first point where I want to measure, and I'm just using the Z-axis, zero out. It's the same function you use when you actually are finding the top of the whatever you want to build. In this case here, I do not have a small steel plate, and I do not use a bit, but I just use this switch. So now you can actually see here how it goes down, and when it hit, it gets red for a moment, and then it raises again, and it raised to the point where it started. And the number here, the difference from zero, is the tolerance I have in the switch, and it's not much, as you can see, but I do multiple passes or multiple tests at the same location just to see how much it actually differs from every time. So I do this, yes, a lot of times, and it's kind of coming near and near to me that the tolerance is about 0.01 1/100th of a millimeter. So it might be okay, it's probably valid for a switch like this. So after I've done this a couple of times in the same place, I start looking to move to another location and do the same, and now I can try see how much it actually differs from the first point to the next point and to the next point. And here in the first place I will measure 3 points in the same row in the start of the plate, and I will just again take multiple tests, multiple numbers to see what is the tolerance, and from that I can kind of figure out how precise this is switched for this purpose. And as it is now, I think it looks okay. It does not have to be rocket science or whatever, so it just have to be a hint where am I when it comes to the straightness of my SpoilBoard or my bed here. So the next sequence, you can see that measuring again here, and then I look at the height difference, and then I go back again. What is it here? So now I start get some numbers, and again, if the tolerance, let's say it's 0.01, it's not much that it actually differs. So now I just go to the two last positions here, and then I will start moving to the rest of the plate. So I will have around 200 millimeters between the points when I start. But first, this is the last time for my tolerance test, and again you can see or get an idea how it actually is when it comes to this greatness. Okay, I go to the first point last time, and from here I start to move, and I start to move in the y direction, and again, yes, about 200 millimeters, and then I measure that point, and now I start to write it down on a piece of paper. What is the numbers? That is a function in the software I'm using, but it's not available for this controller card I have here. So it's manually, but since it's just taking a lot of time to write it down, I'm just sitting down and enjoying that it actually is moving and measuring, and every time it has measured, come up with a number, I write it down. So later I will put that into a matrix. I have another software, you probably know that, or some might know it, it's called Candle. It do have a way to put in all the numbers as you can see here, and then it shows in colors how is it actually, and the red one is going down, the blue one is going up, and the green is almost the same. So it's not that big difference. And if you look in the bottom of all the numbers, you can also see that it's very close to be, I will not say zero, but within 5 millimeters or something like that. So I think that's pretty okay. It's easy to surface later if I want it to be 100% straight and follow the CNC. Now I will just continue. I will build this corner where I can have my top SpoilBoard. So every time I have that SpoilBoard, I can just put in that corner, and then I can just tighten it down with some screws. I will show you later. Right now it's all about mounting the MDF to the plywood, and yeah, it's just some drilling some holes, putting some screws in, tied it down, and I don't think I'll say much next couple of minutes. Here I'll just show you that I mount this corner, and it gives itself what's going on. In the front here I just use some regular screws, and not a bolt going all the way through. I don't need that. I would like to have this piece of wood in the, you can say in the front, being very easy to unmount if I want to have a plate that will cover the whole area, something like that. When I mounted these two boards, I would like to use my CNC to straighten the lines so I get it 100% following the CNC. And for this purpose I choose the bit that, well, to be honest, that was not the most smartest bit to use at that point, or this point of time here. I didn't have many other bits like some of the spiral bits. That's actually much better to use for this purpose. So I just took a bit from my normal router and put it into the spindle and just fired it up. And as you also can see, also in a minute, it's getting black, it's getting hot. I'm just running too slow. It should have been run much faster. But also at this point I didn't give much for the feed and speed. I knew that there was something called that, but to me it was something I had to dive into later. So for now it was just try to get it up run, and I just used what I have by hand, and in this case it was this bit. So now it finalized the straight up of these two boards. So they should be in 90 degrees angle now. And the next part here is, as you can see, I still use the same bit, and it's not the best bit to make a plunge. But since it's MDF, I just used it anyway. It worked okay. So in the first place, I just needed to make a hole for the head of the screws so they could be sunk into the MDF. And it was possible after that to make the surfacing without hitting the top of the bolt. And here you can see that it fits. The bolt goes about halfway down. So there still are some of the MDF to tie down to the plywood beneath the MDF plate. And the next thing is I pack drilled some holes for the size of the thread, or size of the screw. It was an 8mm, so it was just to run the same setup again, except that this time it was just pure drilling. And then I actually didn't show here that I put in all the screws and tighten it down to the plywood. So instead I'll just show you that then I started up playing a little with the surfacing, trying to figure out what was the straightness again and how much should I actually tam the CNC setup so it will be straight. And I was actually in a positive way surprised because it actually seems to be pretty good. Of course, if you go close, you can see there's a small deviation in height, but it is not that much. So I'm just playing a little around with some speeds here, trying to figure out how fast to run this bit, the surface speed, and also how fast to run it for the feed rate. As you can see, the feed rate is not that much. I might speed the movie a little up, but I think to remember this is about 800, something like that. I was not sure how fast to run with it. I could probably have gone into some software and figure that out, calculate a little, but it's still MDF. I'm not afraid of this. And the main purpose here is just to play a little and see how straight the CNC itself is and just have it work. See that it's doing what it's supposed to do. It's still in a test phase. I haven't done much on it yet. So here you can see that I changed the speed a little, so I go up to 2000mm in the feed rate per minute. So it went a little faster. So, and also here you can see there's a little difference where it has actually run. But when you feel on it, it feels very smooth. So I would say that's okay. It's within the tolerance, at least for the tolerance I think I have to use for the purpose here for my setup. And the next thing I want to do is drill some holes for some threaded inserts. These threaded inserts are going to be mounted in the MDF, and then the inside also has a thread, and in this case it is an M5mm thread. And the reason why I'm doing this now is I put these inserts so I can mount whatever I want on top of the MDF. And of course also I want to mount my wasteboard or SpoilBoard later, so it can be tied down and keep in place while I'm working with the CNC. So here I'm just showing, I just pick a random size. I didn't want to put in, let's say for every 10, 100mm, something like that. I think here I'm using every 40mm, and it is sufficient because I just need these to be located so it is possible to use them if I want to hold something down later, a bigger piece. And if it turns out I need to have more of them, they have to be located otherwise or other places, I just drill a new hole and then I just put in an insert in that particular place. And now for the SpoilBoard itself, as you can see, it's not that big in size. I don't need to have a SpoilBoard for the whole bed. In the first place, I just need for some smaller pieces. So the first thing I'm going to do here is create some holes so I can use these holes to tie it down to the MDF below. So I need to drill some holes, that is right over the top of the inserts I just put in the MDF on the bed, so I can tie my SpoilBoard up to these holes or these inserts. And now I got a little wiser with a bit, as you can see right now. I've found, or I actually think I bought a bit that was more perfect for doing these holes. And this is the layout, what I want. And on the SpoilBoard I want to have more inserts. They have to be located more close, so to speak. And they will be divided in 150 millimeter in Y and X axis directions. Here you can see all the holes that has been drilled by the CNC. I didn't go through the MDF, so I have to drill myself the last part. So it's just to start from one end and drill all the holes. After drilling all the holes through, now it's time to put in the inserts. And again, it's just to start from one end and just put in inserts in all the holes. If I need more inserts later, I can always drill a new hole, put in a new insert, depending on the workpiece I want to work with. And I think this is actually pretty okay to do it. I tend to see many people on the YouTube putting a lot of effort in having a lot of these in the beginning. I think it's maybe not the effort worth. So now I just sand it a little down to be sure that it will flush with my MDF board. And here you can see after mounted it, that is for the clamp. So that is for the next episode. I will show you how I clamp stuff. So see you next time. Thank you for watching and have a nice day.